All right, let me see. This is going to be 2.6 homework. That's what I want it to use, is the word problems here. Really, in a sense, go through the homework almost one by one, if need be, okay? And so you guys have to tell me which homework. Is it one and then every other one after that?
Yeah.
Okay, you just tell me when to stop, okay? And we'll go from there. So number one should be the easy one here. So the sum of a number and 5 is 13. Find the number. So cool. So here's if you want to define everything, that's fine. That's what I'll do. This is from the textbook. This is the paper pencil homework from the textbook here. So 2.6 homework from the textbook. I'm going to define what x is. X is a number. We good? Or the first number. I think that's the way we defined it on the work. Say again?
What is the chapter called?
Chapter is Monday, right? When we take the test, yeah. So this is so anything
For the
all
paper or online?
The paper.
Monday when you guys come and take the exam. So for number one, x is equal to a number. So the sum of a number and 5 is 13. Oh, cool. I think I'm ready for the formula here because I don't need to define anything else in terms of x, right? The sum of a number and 5 is 13. We're good there? Of course, this is the easy one of them all. Wish all of them were that easy, right? Okay, so let's go for it here. Boom, boom, subtract. And we have x equals 8. And again, find the number. And again, as an English sentence, even though the book on the side actually doesn't say it. So I'll say the number is, I don't know why that's doing that, 8. It's supposed to be saying number. The number is 8. Okay, we good there? Number, yeah, let's see if I can do number 5 right over here too here. I think I'll probably squeeze in number 5 here. Hey. All right, number 5. 5 times the sum of a number and 7 is 30. Ooh, this one's a little bit different here. So again, we have this little guy saying a number. And I don't think we need to define anything else in terms of the number. So that's it. So now as we go on to, let's see, 5 times the, ooh, this is weird. 5 times the sum of a number. So see if this makes sense here. It says 5 times the sum. So that means I'm doing something that looks like this. We good? I'm multiplying a sum of something. 5 times the sum of a number and 7 is 30. I think you guys can solve that one. So you would not put it as 5x. The reason for it is because just the wording itself. If it said 5 times a number plus 7 is equal to 30, that's when you do it. Or 5 times a number plus 7 is 30. But if our wording here is 5 times the sum of a number 7. So it's really just the wording of it.
I want you to get the result of these two numbers together first.
Okay, so distributing the 5, because that's the only thing I can do here, so I don't know why they're doing this little weird, it's word problems, so these little double forks are popping up here everywhere. Yeah. Be stalagmites, right? Yeah.
Yeah.
That's cool. All right, subtracting 35 from both sides, and that's an easy one because that becomes a -5. Divide through by 5. And we get ourselves x is equal to -1. Boom, 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 boom. I'm very tired. Mr. H, why did you give us that much homework then, right? Okay, 1, 5, jump to 9. Number 9 now. All right. A one number is 4 less than 3 times another. If their sum is increased by 5, the result is 25. Ooh, okay. This one's the toughie here. So x is Looks like I have two numbers on my hands, right? One number is 4 less than twice another. There's some. Okay, so hold on. Then I'm going to really put this down. I'm going to say this guy is the first number. Then I'm going to have to do something to give me a formula for the second number. Second number says one number is 4 less than 3 times another. So one number is 4. Let's see if this makes sense. Remember, 4 less than means we're going to go like this, right? We're subtracting from something. 4 less than 3 times another, but our another is really going to be our first number. Good there. So because we define a variable as x, right? And then we define that second number in terms of x. Okay. If their sum, okay, hold on. So let's bring this down. If their sum, which is the sum of x and that guy, if that sum is increased by 5, so that means we're adding another 5 here, not 15. Increased by 5, the result is 25. Okay, are we good there? I think once we get to the equation, that's a lot easier, right?
Always.
So I'll give you guys a quick minute here, finish it off yourself. And what do we need to know? Number 9 says find the numbers. So then you tell me what are the numbers this time. All right, I'm going to go for it here. So I can drop the parentheses here because there's no need to distribute anything. And then I'm going to simplify each side. Of course, the left-hand side is the one that needs simplified. 3x and 3x and 1x makes 4x, and minus 4 plus 5 just makes a extra 1 over here. And see if you guys can do this here. Instead of like putting a minus 1 on the bottom here, minus 1 on the bottom, just real quick here, see if you guys can do this here. Look at this. So 4x is here, right? And then in your mind, subtract 1 over here, subtract 1 over here. Is that cool? Like that? And then at this point, you can say to yourself, okay, well, hold on. If I divide both sides by 4, 4 is going to be gone over here, and that gives me a 6. Nice. Okay, now I got x. So I go all the way back up here and say, gotcha. I got x is equal to 6. My second number, though, is 3 times 6 minus 4, whatever that's going to be. In this case, how about 18 minus 4 or 14? Are we good there?
Yeah.
So the numbers are 6 and 14. Boom. All right, next one. I think we got 13 on our hands, right? 13. All right, let me read it here. Cody is twice as old as Evan. 3 years ago, the sum of their ages was 27. Okay, let's go for it here. So again, we have to define what in the world is going to be x. Cody is twice as old as Evan. So which one's the one that's being compared to? Evan. Cool. Evan's age, I guess. That's what we'll do it. Good there? That means Cody's age, again, is going to be 2x. Good there? Boom. Okay, now, remember this little chart? It's actually been set up over here. I set up the chart. Let me just recopy it here. So Cody, Evan, and the H probs all work exactly the same here. And so 3 years ago. Whoa, that's weird. And now. Okay, now I think we have now already, right? Evan is X. Then Cody, that means it's 2X. I filled in that column. Now we know 3 years ago.
So the number is -3.
Each of those numbers can be subtracted by 3 here. So 3 years ago would have to be a 2X minus 3 for that column because it's 3 years ago. And the now column for Evan now would be 3 years ago would be X minus 3. So what does it say? 3 years ago, their sum of their ages was 27. Cool, cool. Let's go for it here. So that means the sum of 2X minus 3 plus X minus 3 was 27, and that's what we have to solve. All right, and again, give you guys a minute here. Try it yourself, finish it off yourself, and give me an English sentence that gives me the age of who, and of course the unit, which is years.
We're always just focusing on the first column, right?
Yeah.
Or last column.
To set up the problem, usually what happens is you know what's happening at a certain time. So you're going to fill up one column, whether it's this one or this one. And then what's going to happen is, based upon the relationship now to 3 years ago, then you're going to fill in the other column. And then there's a rule for that. So it said 3 years from now, the sum of their ages will be 27. That means you would add 3 instead of subtract 3. So just depending what the column is saying. All right, dropping the parentheses here, adding like terms together. 3x minus 6. Ooh, this is a toughie here. Let's see. Can you add? Thank you. Add 6 to both sides gets you 33. Divide by 3 gets you 11. So cool. Now let's go back over here. If we go over here, Evan's age then has to be 11. And then Cody's age would have to be, whatever 11 times 2 is 22. All right, so now let's write an English sentence including which number belongs to what person, the number itself, and the units here. So Evan is 11, and then again, the whole concept of a unit here. In this case, it's going to be 11 years old. And Cody is 22 years old. Boom.
Oh, now.
All right, I'm going to try 17 here. And again, number 17 is very similar to 13 here. So let me just start it up here. Hopefully you guys are ahead of me here. So Jack is twice as old as Lacey. So all of a sudden here, everything is compared to Lacey. Lacey's age, Jack is, so again, 2x. Jack's age. We're good? And weird stuff there too. This should be Jack's age. Okay, now for number 17, really the only big difference is they don't have the little box for you to fill out anymore. But that's okay. As long as we can make the box ourselves, we're doing good. So boom, boom. Boom, boom. There it is. So we have Jack on top. I've got Lacey. Now let's see. I'm going to fill it out like the previous one is here. So now is at the end. It says in 3 years. So now it's in 3 years. Okay. Cool. I think I can fill this out now. So Lacey is X. Jack is 2X. In 3 years from now, that means it'll be a 2X plus 3 this time. And Lacey would be X plus 3. So now we're going into the future here, adding in their ages. In 3 years, the sum of their ages will be 54. Okay, so now let's set it up here. 2x plus 3 plus x plus 3 gives us 54. Let me bring it up top over here so you guys can see it. drop the parentheses here, so 2x plus 3. X plus 3 gives you 54. All right, putting together like terms here, how about 3x plus 6 this time is equal to 54. All right, let's do it professionally here. Subtracting 6 in our minds, so 54 minus 6. 48, perfect. Boom, boom. Cool, and then from here on out, you know we're going to divide by 3, so then the question is how many times does 3 go into 48? 18, I don't think so, but close. Yeah, I think it's 16, yeah, because then you got to just check it on the side here, 16. Let me just check real quick just to make sure. So that's going to be 18, and then that's going to be, yep.
It's not close like the price is right.
Sig.
Under. It's gotta be under.
Oh, that's right. The price is right.
I was over.
Yeah, you have to be less than or equal to the number. That's right.
I wasn't close.
Never mind. Sorry.
Yeah.
Mackenzie, you're not. Yeah, no. No reward for you. Okay, so that means Lacey is 16. Double that makes Jack be 32. So again, the sentence in English here. Lacey is 16 years old. And Jack is 32 years old. There it is. All the stuff in there. Bless you. All right, now the question is, it's all about what the question is asking, right? So the question is, how old are they now? The question could also change up and just say, how old is Jack now, right? Or the question could say, how old was Jack 10 years ago? All right, so then if it was 32, then the answer would then be 22. Okay, so it's all about in the question, what's happening there to finish off the problem. Okay. Jumping to 21 here. 21. All right, now we've got some geometry problems here. We did the number problems, so we did the age problems already. Now we jump to the geometry problems, and after that we have the coin problems to do. So 21. Perimeter of a square. Automatically, you hear that? I put up a little diagram of a square. And all of a sudden, I have some variables already put in for me because I know that S represents the side of a square. Now, if you want to, you can actually put X. X is fine. But if you want to stick with the geometry formulas in the textbook, it'll be S. The perimeter of a square is 36. Okay, cool. Remember, with perimeter or area, we would usually write it inside. P is for perimeter, A would be for area. And then what we do is we go back and say, okay, what is my formula? Says find the length of one side. I go back to my little page, geometry page, and I said, oh yeah, I remember that. Perimeter of a square, because all the sides are the same, it's really just 1s. Oh, sorry, 4s, because there's 4 sides, so 4 times s would give us the perimeter. Perfect. All we just do is put in whatever we know. So 36 we know. 4 we know, s we don't, but we will solve for it. So at that point, that's the easy part here. So we got ourselves 9 is equal to s. So the perimeter, what is the length of one side? Okay, now we got to think about here. So inches. So the length of the side is 9 inches. There it is. So then I'm saying what it is. It's the length of the side, how much it is, 9, and the units, inches. good. Number 25. Says one side of a triangle is 3 times the shortest side. The third side is 7 feet more than the shortest side. Perimeter. Okay, hold on, real quick here. Better put this in here. Triangle. Doesn't matter what shape you put it, as long as you got a triangle there. Okay, the perimeter is 62 feet. Find all 3 sides. So at this point, kind of careful with your diagrams. I don't want to know the height here because there's not talking about the area. Good. I just know that it's A, B, and C, right? And then I say to myself, okay, hold on, go back to that page number in our textbook. What was that page number in the textbook that had those geometry formulas? Page 19? Ooh, that was a long time ago. Okay, so the page number I'm referring to here is page 19 in the textbook here. That's the one that had the perimeter and area formulas for each of the geometry stuff. So notice for triangle, it's ABC. It doesn't really matter what order it's in. Okay, so referring to that. Cool. So we're talking about sides here. First of all, perimeter is 62. That's cool. I can do that here. That's going to be 62 in the middle with the P equals. Next is this little part right here. Look, so one side of the triangle is 3 times shorter than the shortest side. Third side is 7 feet more than the shortest side. What is everything being compared to? The shortest side, huh? Okay, so we're going to make one of these guys to be the shortest side. So I'm going to say, you know what? A is going to be our x value. We're good? And if we want to define it here, x is shortest side. So I've defined what x is. And I labeled one of those sides as the shortest side called x. Okay, the other ones, I don't think it really matters which way you write it. Which one's B, which one's C. So one side of the triangle is 3 times the shortest side. Oh, that's cool. Okay, hold on. So there's B. I'm going to pick B, so we go in order here. That means this guy is 3x is perfect. So define this guy 3x. Boom. Okay. The third side is 7 feet more than the shortest side. Hold on, I got C. C is 7 feet more than. Remember, with more than or less than, it's going to work backwards, right? So the x plus 7. Good there? Because more than. Cool. And then we look at the formula on page 119. It says perimeter of a triangle is A plus B plus C. But we're going to plug in all the stuff we know here. So I got a 62 here. A, if you want to put parentheses in here, that's cool by me, because then you're sort of really being mindful of what you plugged in. B is 3 times x. And C is x plus 7. Cool. All right, give you guys a minute again. See if you can solve this guy. All right, once you put all that in, again, we can drop all the parentheses because no distributive property here. So x plus 3x plus x plus 7 and combine like terms. Let's see, x, 3x, and another x. That would make 3, 4, and 5. So 5x plus 7. So in this case, notice our x variable is on the right-hand side. That's still okay. Divide by 5 here, and we get 11 is equal to x. Of course, that's not how we're going to keep it. So we're going to come back over here. If that's the case, that means this guy is 11, right? That means this guy has to be, we can all multiply by 3. And this guy is going to be plus 7, makes 18. So now, what is the question? Find all 3 sides. Cool. So again, the 33. Sides are 11. Now we gotta make sure that we put in the units here. What units are we in? Feet. Okay, cool. So I'm gonna do the abbreviation here. 11 feet, 33 feet, and with a little spike to it, 18 feet. There it is. There's only 3 sides. All right, moving on. 29 is what we got next here. All right, I like 29 already because it has a diagram already for us set up. So the length of a rectangle is 5 inches more than the width. Awesome. Perimeter is 34. Awesome. So really, without writing anything down, I have everything I need. I have x plus 5 here. I have x already. One thing I need to include more is just to say that p is equal to 34 in the middle there. And then I need to go and grab my formula for perimeter of a rectangle, 2L plus 2W. I like this one. 29 was a pretty good one. So P is 34. Got that. That's 2 times L, which is 2 times x plus 5. Now we do have distributive property on our hands here. And then the width is just x, so it's 2 times x. Ooh, finally, distributive property here. Okay, there's our setup. That was an easy one to set up because the diagram was already there sitting for us. So again, give you guys a minute, finish it off yourself. All right, and here we go. Distribute the 2 here, 2x plus 10. This is going to be 2 times x, which is 2x. And then collecting like terms together, 2x and 2x makes 4x. All right, it means sophisticated math. 61 students, here we go. I can subtract 10 from both sides. It gets me a 24 here. Awesome, without even showing the steps. We're so cool like that. Divide by 4 on both sides, and we say that it's going to be a 6. Okay, if that's the case, we go back up here to our diagram here. That means that x is equal to 6. This one's going to give us a 6 plus 5, or 11. And the question is, find the length and width. So I got to tell me which one's which. Give me units as well. So the length is 11. So let me write that correctly here. 11 inches. And the width is 6 inches with spikes. Okay. Okay, good there. Uh, 33, I believe, is the next one. 33, the only change there. It's 33, right? I think it's 33.
Yeah.
Okay. It does not have a little diagram that we like. So 33, the length of a rectangle. Once you say that again, I'm going to just put a little diagram down. Boom, boom, boom. Okay, now with the rectangle, I know, real quick here, I know I have a length and I know I have a width. Good there? So I set those up already here. The length of a rectangle is 6 feet more than twice the width, blah, blah, blah. Perimeter is 36. So whichever one I do first here, perimeter or length here, it says the length of a rectangle is, well, I'm going to set this up 6 feet more than 3 times the width. So in this case, it can be 3 times x. Good there? So then the width, everything's going to, the length is compared to the width, so therefore the width has to be the x for us. Okay, good there with the x's or the w's changing in that. And then the perimeter is 36. All right, all yours. Can you solve it from here? Put it into the formula and solve it. Give you guys a minute or so. All right, let me start it off as well here. So off to the side here, formula for perimeter of a rectangle 2L plus 2W. And P we know. L is 3x plus 6, and the width is just x. All right, 6x plus 12 plus 2x. 8x. Let's subtract 12 from both sides. That's going to give us a 24 because we're so sophisticated like that. Divide by 8 on all sides gives you a x equals 3. So again, we go over here, we say 3 is here. This one's going to be a little more here. 3 times 3 is 9. 9 plus 6 is 15. If you want to, you can put equal signs here as you go down. But we got it here. So the length is 15. I gotta go back. Feet. Perfect. Thank you. And the width is 3, right? 3 feet. Let me do that a little different. The way that went out. 3 feet. How about that? Ta-da. Okay, next one. 37. 37. Let's go for it. 37 now are the coin problems. The coin problems. And remember, whenever you say coin problem, you're going to put it into these categories right here, right away, right? With lots of spikes here. Okay. It's going to be this little 9 boxes here. If you can fill in 9 boxes, you're doing good. The column or the rows are going to be always number, and they have your value right there. If you can set that up, and I like to do it just slightly different than the textbook here. The textbook is different. And then we're going to figure out what we have here. So there's a Tanner has $4.35 in nickels. Ooh, I got it. Here you go. Nickels. Nickels and quarters. Okay. All right. If he has 15 more nickels than quarters, got it. Already know this here. So the nickels are being compared to quarters here. So the X would be number of quarters. We're good? Because nickels is based upon how many quarters you have. Okay. So if that's the case, I got X for the number of quarters. We're good? He has 15 more nickels than quarters. I got it now. That's cool. So the number of nickels would be how many quarters the guy has plus 15. Okay, and here's what I do a little bit different than the textbook. Is I just put down the value of a nickel, of a single nickel. The value of a single nickel is worth 5 cents. The value of a quarter is worth 25 cents. Good? And then what we do is we multiply down to get our equation. I think that just kind of makes a little more sense. So what we're going to do is we're going to multiply these guys together. So the ultimate value of nickels would be 5 times x plus 15. Of the quarters, it would be 25 times the number of quarters they have. And the grand total has to be $4.35 or 435 cents. And we talked about it last time. Instead of putting $4.35, then we have to deal with the decimal stuff. This way we get rid of the decimal stuff already. Right, and multiplying in here. So 5x plus, anybody 15 times 5?
Oh, 75.
75, yep, I'll go with that, yep. So 25x, and we get ourselves 435, perfect. Let's see what I got here. 5x and 25 more makes 30, so I got 30x plus 75. Make it into a better 5 looking. Okay, in this case, with bigger numbers here, you may want to show exactly what you're doing here, just to make sure that we got it all good here. So 5 minus 5 is a 0. Got to borrow this time here. So 3, so that makes 13. 13 minus 7 is a 6. Then we bring down the 3 here. Oh, cool. I think I know this one pretty easy. If I can write it nicely. That'd be 30x is equal to 360. And this one's pretty easy to solve because when you divide by 30, whenever you have fractions here, you know zeros are going to cancel each other out right away. Boom. So then really it's 3 going to 36. It'll be 12. Okay, so let's go back a little here. That's going to be the number of quarters, right? So if you need to, you can just kind of make a big old arrow up or something like that. Just say that's 12. The number of nickels, though, is going to be 12 plus 15. Cool. I heard 27 in the whisper. Yep. So then, English sentence. Here we go. Tanner. Oh, let's see what it says. How much of each coin does he have? Yeah. Tanner has 27 nickels and 12 quarters. Da, da, da. Exclamation point. Okay, maybe not. How about just a little period? Okay, fine. All right, how can I make 37 more difficult than it is right now already? Is put in another coin in here. So 41 now has 3 coins, or 3 different types of coins in here that we've got to think through. So 41 is kind of nice because they did give you a little chart to go with here, so that's kind of nice. They already set up a little bit of a chart for you here. So in that case, instead of having, oh boy, here we go. Instead of having 9 boxes to deal with, $12 boxes to deal with. Okay, but still, as before, number and value. So Katie has a collection of nickels. Here we go. Nickels, dimes, and quarters. Okay, let's see what's everything being compared with. The total value of $4.35. Hey, Tanner and Katie are the same. There are 3 more dimes than nickels and 5 more quarters than nickels. So what is everything being compared to? Nickels. That's the base. So number of nickels. Cool. So that's going to be X. Boom. Goes right inside there. So the rest we're just going to get in for the number here. So let's go back here. There are 3 more dimes than nickels. 3 more dimes than nickels. Perfect. Right there. We got X plus 3. The more than working backwards here. And 5 more quarters than nickels. Perfect. If you said X plus 5, doing great. All right, value in terms of cents here. So nickels are worth 5 cents, dimes are worth 10 cents, quarters are worth 25 cents.
Okay, so that's how we did this.
So the worth of them. In order to set up the sum formula, all we do is we just multiply down. So 5x, this one multiplying down, plus 10 times x plus 3, plus multiplying down, 25 times x plus 5, grand total of 435 cents. Give you guys a little time here. Try to solve it yourself here. A quick minute. And I'll solve it as well. All right, let me try this here. Let's see if I can finish this off here. So 5x, 10 gets distributed. So now I got myself a 10x plus 30. Ooh, 25 gets distributed. How about 25x plus 125? Okay, totally running out of room here now. So let me go all the way over here and start combining like terms here. So 5x, 10x, and then 25x. 40x, I'll go with that. 30 and 125. 155, perfect. So 435. So then I subtract 155 from both sides. Again, I probably have to show it what I'm doing here. Okay, just with a little bigger numbers here. 5 minus 5 is 0. Let's say I got to borrow now. So 3, and that makes 13. 13 minus 5. 8. 3 minus 1 is a 2. Cool, I like this here. I like when I have zeros in my denominator here. So zeros go away. Boom. So x is equal to 7. Cool. Okay, now going back, because again, everything has to make sense here. The number of nickels, 7. Good. Number of dimes, 10. Perfect. And number of quarters, I got 12. Good. Boom. Whew, final sentence to write. This is good here. Katie, I think that's her name. Yeah. Katie has 7 nickels, 10 dimes, and 12 quarters. So, if you need to borrow some money, you know who to go to. All right, so that is really the end of, I think, 2.6 homework. Is that right? All the word problems are done. Yeah.